Hi, my name is Gregory Darren. I am a technology education teacher here at Darien High School, and I'm also the 612 department coordinator. This is what I look like without a mask, which is a rare sight these days. I am a Central Connecticut State University graduate. I graduated with a master's and undergrad degree in technology education. I went back to school in about 2016 for my educational leadership degree at University of Bridgeport. And this marks my 18th year in the classroom, with 7 years here at Darien High School. Prior to Darien High School, I taught for 7 years at Oxford High School in Oxford, Connecticut, and I taught for 5 years at Woodland High School in Beacon Falls, Connecticut, and I started my career out at Crosby High School in Waterbury, Connecticut. I am a dad of 3. I have a 11-year-old daughter who just started the 6th grade. I have a 9-year-old daughter entering the 4th grade this year, and a 5-year-old son who just started kindergarten. I am an avid DIYer, just with projects around the house to improve my home and fix everything that continues to break, whether it's plumbing, electrical, or replacing windows or building a deck. I've done it. In our Independent Projects in Engineering course, it's a course that was modeled off ASR, the Applied Science Research course, but has a heavy kind of focus on the engineering design process. Students will make a 2-year commitment. They will start this in their junior year, focus on a project that will most likely carry into their senior year. However, we have made exceptions for seniors who expressed a lot of interest in this course and made accommodations to make it work for their senior year. This course meets every other day under normal circumstances, in hybrid circumstances, or during full remote learning with our new schedule. We meet on a half of a block, which is probably about a 45-minute period. The opposing time when they're quote-unquote free would be lab time. It's independent work where they will focus on their project, whether in the lab or at home doing research, whatever their project may entail. The project relates to the engineering design process, where we will determine some type of problem or need within our society or within our personal lives and try to come up with solutions to improve or fix that problem. Students will come up with ideas and designs and drawings, which will develop into models and prototypes and into working models. Then we will evaluate those models, test them out, see if they work, grab some feedback from other students and staff, and continue into a redesign to improve. And this design loop is a continuous loop where we can continue to improve upon our designs. Initially, that we're starting right now, especially for juniors, is a focus on materials processing. So we have an understanding of how things are built and how we can make things to hope to spark interest in different types of projects that they may want to move forward with. This is what our labs look like. This is our woodworking area. We have some table saws, some band saws, a drill press, and a cross-cutting chop saw or miter saw. This is a vertical mill that's used for milling and shaving down metal. We also use it for wood as well. And this is a metal manufacturing area here. We have a couple welders, a metal cutoff saw to cut metal down to shorter sizes. We have some grinding wheels and a plasma cutter to help us cut through metal a little bit more efficiently. This is a little bit more on the automated side. We have a CNC, which stands for computer numeric control router. We have a CNC mill that will cut through some metal or soft plastics. And this is a laser engraver and cutter. It will cut through very thin wood or plastic, and we have a 3D printer here. In each one of these cases, the designs will be made on a computer. It could be through a CAD program, computer-aided drafting, or it could be through a printing program like Adobe Illustrator to print to a laser engraver. The CAD programs will get sent to the CNC or 3D printers, and that geometry will get turned into G-code or coordinates, if you will, where the machine will follow a certain geometrical path to cut out the design that the students make. once the students learn how these different machines work and how they process materials, hopefully that will shape and guide them to determine what type of projects they want to do, or how they want to learn more and develop their skills so they could focus on that engineering design process that I talked about. So right now in class, we're working on how to utilize these machines, what they can do, and within a week or two, students will start diving into different types of projects that they want to get involved in this year. If you have any questions or comments, feel free to reach me via email at gdarren@darrenps.org, or you could follow me on Twitter at GJDCT, and I hope to post some of the awesome projects that the students are working on throughout the year there as well. Thank you.